Good morning. Let us pray. Dear Lord, we thank you for the gift of life. Thank you for the gift of everything you've done in our lives. We thank you for the fact that we've made it to this morning session, Lord Father, and we thank you for each and every one of us in this meeting room. Lord Father, as we study and as Mr. Kasiwa disseminates information to us, Lord, may we understand it very fast. May we apply it and we pray for maximum levels of focus. Pray against all forms of distraction, Lord Father, and pray for overall progress. We pray that you may bless him for his efforts, and we pray that you may have a fruitful session, oh God. Help us, Lord Father, to cover what we need to in this time, Lord, and may we have a greater, bigger picture, oh Lord Father. We pray for excellence for each and every one of us here, and a great day. In Jesus' mighty name, I pray and believe.
Amen.
Amen.
Thank you so much, Alice, and good morning, everyone. Thank you so much for joining in and for being on time. So today we are going to look at what we call vector product, or what we call the cross product. So that is the concept that we have been that we are going to look at. Where do we apply this concept? Many times when you are opening a door, this concept is applied indirectly. This concept of cross product, but it is mainly used when we are looking out for the direction that our force is going to take on. And what do we call a cross product? Now, by definition, when we have two vectors, like when you look at my screen, this is one vector we are calling B, and this is a vector we are calling A. Now, if we are interested in finding out the vector that is perpendicular to both A and B, then what we do, we call it the cross product. Now, I want you to take note that cross product and dot product are totally different. That under cross product, once we cross two vectors, we shall end up with a vector. But when we dot two vectors, we end up with a scalar. So by definition, when we have a cross product of two vectors, we shall have it in this format, whereby sign here under cross product, we shall have a sign, whereas when we are looking at the dot product, for it we have a cos theta. So now you need to know those two differences, but we are going to explain going forward. So I want you to write now the definition of what we call cross product, and then we are going to go through how do we approach cross products. So let me ask you to first take note of it, and then we start. But whenever we are finding the cross product, they must have a common reference point. Yes, that one, you should take note of it. When you finish, you let me know and we okay. 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 In case, let me say, in case this is a vector, let me say this is A and this is B and this is point C. Now, in case I want to find the angle that is going to be perpendicular, or in case I want to find the direction that is perpendicular to both vector AB and AC. So here, when I'm finding its cross product, I'll say vector AB. So A is what we call the reference point, that they have a common point where they start from. So I'll say AB cross A to C will equal to the magnitude of A to B, magnitude of SC, then the sine of the angle between the two vectors. Now, this A and the A is what we call the common point, or what we call the reference point. In case, let me say, I have another vector. I join this. In case I want to find the direction for the two vectors that is perpendicular, then in case I have considered to use C, then that means that if the common point is C, then I'll use C and B, and then I can use C and A as my vectors. And therefore, I make sure that the angle in between is the theta. So that's what we call the common point, or what we call the reference point. Are we good to continue, members? You can let me know through the chat. Okay. Now, those who have been to garages, those who have been opening, let me say you are opening a door, you are unscrewing something. Yes. Now that concept you have been applying is what we call the cross product. It determines the direction you are going to take. An example I can give you, when you look at this screw here, are you seeing this screw? When you are opening it, this direction you take, that I'm going to go like this, I'm going to go like this, I'm going to go like this, that's what you call the cross product. So it's not that a matter of you just opening anyhow. And the moment you go you go opposite to the direction you are supposed to take, things do not open. That's when you have zero. You are trying like you are trying to fix something, but it's not moving at all. Like when you are trying to unscrew something, whenever you find yourself that you are not able to open something, then that means that the cross product is zero. But the moment you find that now it can open, then it means that you are moving in the right direction. Now this X, it shows you that now if I have X and W, my right direction will be up. So there you'll be able to open the screw very, very well. But the moment you find that you cannot open it, then it means that the cross product is zero. Many times when those young kids are opening the door, sometimes you see them just like pushing, and the door may fail to open. So the moment the door fails to open, it means that the direction they are taking is not the right direction. Now, so in that concept, even those who have seen spanners, these spanners here, to be able to open something, that concept of opening, apply to know the direction you are going to take, whether I'm going to go this side or whether I'm going to take that side. That direction of movement, that direction you take is what we call the cross product concept. Yeah, yes. And that one, we shall call it torque. When we come to physics, we shall call it the torque. Now, what do you need to know is that if I have I, this is my I, and I'm crossing I with J, that one you pay attention, because this concept is going to be very, very key. If I have I and I'm crossing it with J, I have I, I'm crossing it with J. Those are my unit direction vectors. Which direction is my vector going to be? Now, we use here the right thumb rule, that if I have I and I'm crossing J, let me make it better such that you can see it. You see what I want. That if I have I and I'm crossing it with J, my direction for the vector is going to be in the K direction. Hope you are seeing it. That when you cross I and K, I and J, you get K. Now, what do you need to know? That we always move in this kind of direction. Now, if I have J cross K here, I have J cross k. That means that the other component that is remaining is going to be my vector. So here it means that I'll end up with I. Members, you tell me through the chat, what about when I have k and I cross it with I? Which direction will our vector be in? Aha, thank you, Gilbert. Thank you. So it will now instead be in the J direction. Now, when you look at our movement, this is the movement using the right thumb rule. But if you take the other direction, let me say you are taking the this is the clockwise direction. Members, you tell me from your understanding, if I take J cross I, which direction do you think we get? I'm just testing. If we get J cross I, yes. So members are saying we get K. But here, the only thing now you need to know that since we are taking an opposite direction, and you know that in vectors, direction is very important. So for that case, we shall get negative K. Not just K, but we instead get negative K. Hope that is okay. So you take into consideration the direction. Members, what about when I have I and I cross it with K? Which direction do we get? Very good. So here we shall instead get negative G. What about when I have K and I cross it with J? Which direction shall we have? Yes, yes, yes. Yeah. And that is very, very important in cross product. The moment you understand these concepts, you'll be able to do it. Now, the last one is, what about, members, what do you think? What about when you have the two vectors in the same direction? Let me say I have I cross I. What do we get? I cross I. What do we get? We have vectors along the same line. Perfect. So when you have I cross I, you get 0. J cross J, you get 0. And then K cross K, you also end up with 0. That is what is very, very important for this whole topic. So for anything we are going to cover today, this is the concept we are going to be dealing with. And the moment you understand it, then everything will be very fine. Yes, Diana.
So I'm asking why is it that when we cross the same we get 0?
Why we cross? One is that we shall not have any direction that we are going to take. Like whenever you are moving, like, okay, let me first draw something. That if along we are at this line here, like when you point a screw and you don't you cannot rotate through any given direction, that when you are in the same direction of I, there is not any kind of rotation that you can take on. So that means that you don't have any direction where the screw can go. So at that moment, that's why we say that for that one we shall have a 0. So maybe another explanation maybe for this one can be that when you are crossing I cross I, here you'll note that the angle between I and I, this is I and I, the angle is 0 as well. So that means there is no turning. The concept of cross product you must have what you call either there is turning, there is an area, and there is some perpendicular direction. So since there is no turning at all, the angle is going to be 0. And once the angle is 0, then it means we shall have our thing as or I can bring it in this from the definition. Let me also use the definition, and then you'll know why. Another why I can use is that, so members, I'm waiting for you to write this. Like when I have A cross B, okay, when I have I cross I, this is magnitude of I, and then I'll have here my sign of 0. Now, sign of 0 means that you end up with 0. So that's why I cross I, you end up with 0. So let me hope Diana, you have been able to pick that. Diana, is it okay or not yet?
It is okay.
Okay. In case I'm explaining it in terms of area, it means that you cannot obtain an area for that particular thing. Okay, members, you let me know whether we have finished, right? And then we can now start. Okay, so people are saying we can go on. We can go on. Okay, we are going to start with this. I'm going to show you two approaches, and then we shall choose which approach we want to use. We shall use two approaches, and then we shall choose which approach to use. Okay, now the first approach. So they have asked us to do A cross B. Let me write them in vector form. So here we shall have 2I plus 3j minus 4k, and I'm crossing it with 3I minus 5j plus k. Now here, each individual component affects the other. Like the way we do in multiplication, that this I will multiply with the I. This I will go with the 5. This I will as well multiply like that. So that is the first approach I'm going to use. Now here we shall have 2I cross 3I. Then allow me to put in brackets. Then I'll have plus 2I cross negative 5 of j plus 2I cross our k. Then I go to the next one, plus 3j cross 3I plus 3j cross negative 5j plus 3j cross the k plus negative 4k cross 3I plus negative 4k times negative 5j plus negative 4k cross k. Members, is that clear to everyone how I've multiplied? Here is like the way we open up the brackets. The way we open up the brackets, let me just put here for you to and like the way when I have A plus B and I have maybe A plus C. When we are opening this A multiplies everything. In other words, you can say A into A plus C plus B into A plus C. So each of them will multiply each of the individual components. Hope it is clear, Gift. Okay. So we are going to continue. Now, when you reach here, we start now asking ourselves, I cross I. You go back and remember, let me draw it here that this is I, this is J, and this is K. So we say that I cross I, we end up with 0. So everything here is going to be 0. So this one can go away. Then I come. I cross j, we say that I cross j will give us a k. So members, for this particular one, I'm going to say 2 times -5, I get -10 of k. Then I come I cross k. So you'll come here and say I cross k. So when I have I cross k, we say that when you take this movement, you get the negative. So here I will say plus 2, but here since it is negative, it's going to be negative j. So you are going to allow me here, I will say negative 2j. Then I go here, j cross I. So I have j cross I. J cross I gives us a k, but negative. So instead, for this one, I'll have plus negative 9. Because we said j cross I will give us negative 9k. Then we come here, j cross j. We said the same unit, we get 0. So this one is also going to give us 0. Then we come j cross k. J cross k is here, will give us an I. So here we end up with 3i. So here I'm going to add on the 3i. Then I come k cross I. I will come k cross I will give us a j. So here we shall have negative 12 of the j. Then I come k cross j. What is k? K cross j, this one here, will give us negative I. So negative 4 times -5, that is 20. So we have 20, but we said since we are crossing k times I, we get that j. I think this is j. Sorry, k cross j, we get negative I. So here I'm going to remove this. And I say here we shall have negative 20 of I. Then the last one, k cross k, we said the same direction, gives us 0. So this one will be 0. Members, are we still on the same page? Okay, Gilbert says yes. Yeah. Okay. Now, after we are going to combine, we are going to say negative 10k minus 2. That means here we have to be very careful with the direction. I and k, okay, towards j minus 9k plus the 3i minus the 12j minus the 20i. That is the first thing, that you have your 3j. Now, when we reach here, what are we going to do? We are going to collect like terms, I and I. Now, when you look at the I, I'll have this I, I'll have this I. So you ask 3i minus 20i. What do you get? That one will give us the negative 17i. Then you go to j. J and j, minus 2j minus 12j will give us minus 14 of j. Then you go to k. Negative 10k and 9k will give us a negative. Then you get negative 19k. And now this is the answer for A cross B when you cross those two vectors. In case you have a question, kindly ask. And here you have to be very careful when you're opening the brackets such that you do not make any errors. Yes, Gilbert.
Yes, good morning, sir.
Yes, good morning.
Now, I have only one question, that here when you like that sketch that you sketched there of the right thumb rule,
Mm.
is the arrangement supposed to be fixed like that, or you can start with K, then J, like that?
Mm-hmm. No, it's not a must that it should be fixed like that. Like I told you earlier on, that those components can be fixed in any way. You can say this is my I, this is my J, and this is my K. What is important is that our movement is anti-clockwise, that gives us a positive. The moment you move in the clockwise, you get a negative.
So 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 if I have a different arrangement and I happen to have my clockwise my move clockwise movements different
Mm.
from this one, can I come up with the same final
You
answer?
get the same answer. Like the way you are seeing here. As long
Yeah.
as you have them like I, J, K in that order, not I, K, J. Like you have I, J, K. So for you, the moment you have I cross J, as long as you are moving in the anti-clockwise, you'll get K. J cross K, you'll get I. K cross I, you'll get that. Doesn't matter how. What matters is the kind of the direction you are taking and the order and following the order.
Okay, thank you, sir.
The answer remains the same. Okay. Yes, Miracle.
Good morning, sir.
Morning.
I'm begging for pardon with the multiplication star.
Okay, you first stay on. You stay on. You stay on. You stay on. And I first give you here some. Okay, now, Miracle, first open for me. How do you open this kind of bracket? Let me say, this is y plus 3. How do you open this? Sorry, Miracle, come again.
You would say
Mm.
x into y plus 3
Mm-hmm.
and then plus 2
Mm-hmm.
into y plus 3.
Okay, good, good. Now we are going to extend it. I have A plus B plus C, and I have E plus F plus G. How do we open this?
That would be a into e plus f plus g plus
Plus.
b into e plus f plus g
Mm-hmm.
plus c into e plus f plus g. Then you
Good.
close the bracket.
Good. Now, we continue now. We come to this number. We have 2i plus 3j minus 4k cross 3i minus 5j plus k. How do we open? Open for me the way you open the other bracket.
That would be 2i into
Mm-hmm.
3i time minus negative 5 plus k plus 3j
Mm-hmm.
into 3i
Mm.
negative 5j plus k
Mm-hmm.
minus 4k into 3i negative 5j plus k.
Now we open. Remember,
Yes.
we are crossing, eh? Do not forget
Yes.
that we are crossing here. So you say 2i cross 3i. Now here you first look at the directions. I cross I. What do you get?
It is a 0.
0. Then you go to the next one. I cross J. What do you get?
So teacher,
Mm.
you don't consider the 2 times 3, you only consider the returns.
No, like you are going to consider them. So I would say 2 times negative 5 is negative 10. Then I say I cross J. What do I get?
That is k.
That is K. So here I'll say that is negative 10K. Then you continue. 2 times 1 is 2. Then I say I cross K. What do we get?
I cross k, that is j.
J. But negative.
Yes.
So you end up with negative 2 J. So like you do like that for all.
Okay.
And then after you collect the like terms.
So teacher, like
Mm.
still on the 2i and 3i,
Mm.
we are going to neglect this. We couldn't say 6 because it is I will get a 0. That is the reason.
Yes. I cross I is a 0. So you have 6 times 0, which gives you 0.
Okay, thank you, sir.
Okay. Yes, Angel. Angel. Okay. Chome.
Good morning, sir.
Morning.
Yeah, so what I'm asking is that if I'm crossing, for example, I've crossed K cross J, and I'm getting a negative I.
Mm.
Yeah. and even as in the digits, I'm also multiplying. For example, I had, let me say, I've crossed negative 2k. Yeah, with a positive j, but I'm getting a negative, let me say negative 2, but even the direction has to be a negative I. So do I consider their resultant to be a positive?
Perfect. Perfect. This negative 2 times 1 is negative 2. K cross J is negative I. So you say times negative I, and it gives you positive 2I. Yes. Okay.
Thank
Hope
you,
that
sir.
is okay, Chom.
All right, thank you, sir.
Okay. Jesse,
Good morning, sir.
morning.
So I would like to know which one is negative. Is it clockwise or anti-clockwise direction?
Okay. When I am moving like this, which direction could this be? The opposite
That
of
is
a clock.
anti-clockwise.
And clockwise. So everything within anti-clockwise is the positive. If you are moving like the way the clock moves, that is what you call the negative.
Okay.
Uh-huh.
All right, thank you.
Okay. Lastly, Dennis. Dennis.
Good morning, sir.
Morning.
Mas, I would like just starting from the next step after opening the brackets. There, that 17, the way it came, it's confusing me.
Which one?
That step after after opening of the brackets.
Here.
No.
Here.
That's it. Yeah, starting from there. The way we
Are you
got to
seeing
that
this K
negative
and this
17.
K?
Yes.
So you collect like terms like negative 10K minus 9K. Negative 10 minus 9, it gives you negative 19K. Now this negative 17 is that you have the 3i and you have the negative 20i. So it's like having negative 20 plus 3. You end up with negative 17i. Hope it is okay.
Yes, thank you, sir.
Okay. So members, I think now we are going to look at the second approach. So we are going to look at the second approach. Okay. Now the second approach. Is using the determinants. That is the second approach. We use the what? The determinants. Now, how do we do it when it comes to the second approach? Like I've told you, for it, we use the determinants. So I'm going to come here and I say that I have my A cross B. So here, I'm going to define it like this. I have my A, you are seeing the A. So I pick the individual components that I'm going to start with my I go back to J, and then I'll have the K. Now, after doing so, I'll extract that I have 2, I have 3, I have negative 4. Then I go to B. B, I have 3, I have negative 5, and I have 1. Kindly first state me whether everyone has understood now the extraction. We are starting now the second approach. Is that fine to everyone? How I have extracted from A to B? Very good. Now, I want you to take note that the next is to give them the directions. That is the next step. And what do I mean by giving them directions? That here, I'm going to start with I, it's going to be positive, J is going to be negative, and then I'll have this as a positive. That is the direction I'm talking about. That this is going to be positive, negative, and then positive. So what are you going to do? Now we are going to start eliminating. So how do we eliminate? I'm going to come, I eliminate this column. I eliminate this column. I eliminate this column like that. So what do I remain with? I'm going to remain with this one. But here, the first one I'm dealing with I. So I'm going to say I. Then I say now I've remained with 3, -5, -4, 1. Then after that, I go to the next one. The next one, I'm going to eliminate j. I'll eliminate this. I'll eliminate this. So when I eliminate that, what do you notice? That now I'm going to remain with, we are on j. So j is negative. So I'll say negative j. Then I'll remain with 2 and 3, -4 and 1. Then after that, I eliminate the next one. So the next one, I'm going to eliminate the k. So under the k, I will do like this, I will do like this. So here I will say plus k, then the magnitude, what have I remained with is 2, 3, 3, and -5. Kindly let me know whether we are still together up to that point. Okay. Okay. Yes, Martina.
Good morning, teacher.
Morning.
Yes, so I've understood the elimination part, but I just want to ask why you're pointing out that, let's say, I is positive, j is negative, and then k is positive.
Okay. I'm going to throw some light. Why we put positive, negative, positive.
Okay.
Okay. Gloria, is it the same question?
No. Good morning, teacher.
Morning.
I'm requesting that you repeat the part for the elimination.
Okay. I'm going to do so. Okay, I'm just still looking through the chat. Okay. Now, I'm going to repeat. Let me first remove everything, and now I first repeat once again. Now, when we are crossing, I'm going to have A cross B, and A cross B, we have different directions. So we have our I, we have the J, and we have the K. Now, what happens is that we extract, and please make sure that you follow the order. A cross B, so I'll start with A, so I'll say 2, 3, -4. Then I'll go and I have the B, so the B will be 3, -5, and I'll go on here and I'll have my 1. That is the first extraction.
Okay.
That is the first thing you do. Now from there, I'm going to come and I will start the elimination. But yeah. Okay. Now from there, the next thing you are going to do, you are going to give them different signs. And the signs here, we start with having this one is being a positive, this one negative, and then this one can be a positive. Similarly, if you are going down, you do the same. This is positive, negative, positive. Even if you are coming this side, you say positive, negative, positive. Even if you are coming like this is positive, negative, positive. It doesn't matter. Whether you like this, like this, like this, like that, any of them doesn't matter. But now I always love using the app. And where do those positive, negative come from? Now, those ones come from what we call, there is something you learn, we call it the determinant and the co-determinant. Okay, we call it the cofactor alternating sign theorem. That's where it comes from. But here, I'm going to bring that idea of why we put the signs after we have got the answer, such that you can know that when we have this and this, something is going to happen. So after that, you are going to come and say, now I'm starting with I. So when we are starting with I have this removed and this one eliminated. So once you eliminate, we are going to stay with I, and then you'll see now what factors are remaining. You remain with 3, -5, -4, and 1. Then after that, you're going to come and say, now I remove this, I'll remove this. Now, the moment you remove that, go to the next one. Go to the next one. So the next one we are going to go with is going to be this one in the middle. I'll come, I remove this, I'll remove this. So that one I'll have -j into what has remained is 2, 3, -4, and 1. Then when you remove that, I'm going to come, remove that, remove that. So now the moment I remove that, I'm going to come and I say, I use this color, I remove this, I remove that. So that means I'm dealing with a k. Then I'm going to have my k, and then here I'll have 2, 3, 3, and -5. So now that is the first step. So kindly let me know whether at least we are okay up to that point.
Thank you, teacher.
Okay. Is that approach at least up to that point okay? Okay. Yes. And one of the uses of those signs is to preserve the directions. To preserve the directions. One thing you need to learn is that whenever we are dealing with determinants in real sense measure they measure area for two-dimension figures. Two, they measure the volume when we talk about determinants. Three, they measure what you call orientation or what you call the directions. So if you do not want to lose those directions, that's why we measure, or that's why the sign is very essential. Yes. Okay. So we are going to Okay, so I'm going to come and now let me call on Martina a bit. Martina, are you still on? Yeah, and you first remind me. Martina, are you on?
Yes, teacher.
Okay. Do you remember how we used to get what we call cofactor or codeterminant? Like when we are dealing with two determinant, with the 2 by 2, let me say this is 2, 3, and this is 4 and 5. How were we getting the codeterminants? What was happening?
Sure. What do you mean exactly by codeterminant?
Like when we are changing, we call it, I think you called it the co-adjoint. Remember the adjoints?
Sure, sketchily.
Okay. Remember,
And
like you used to say, you interchange and then you make these ones negative.
yes, yes, yes.
Yes. Now, like when we are dealing with the two, you used to say positive, negative, negative, and
Negative.
positive.
Yes.
Now, this concept here of of the adjoint is what we are doing here when it comes to signs. So when you have a 3, for a 3, you'll have positive, negative, positive. Positive, negative, positive. Positive, negative. This will be negative and positive. So for a 2 figure, this is where you end. Then when we expand to 3, that's why for it we have positive, negative, positive, negative, positive, negative, positive, positive, negative. So we are applying that kind of concept.
Okay, teacher, I've understood how the signs have come about, but now if I'm to relate it to like what we have now, the I, J, and K, are we putting positive, negative, positive? Because like if you look at like the first row, the horizontal part, it's positive, negative, positive.
Yes, that is one. That is true.
Okay.
Now, from here, what are we going to do? Now, we go back to how we are getting the determinants. You remember how you get the determinant? You multiply the elements along the major diagonal and then subtract along the minor diagonal. So here, I'm going to have my I, then I multiply. I'll say now 3 times 1 minus negative 5 times negative 4. So everything, I'm multiplying it times I. Then minus, I go to the next one, whereby I have 2 times 1 minus 3 times negative 4. Everything, I multiply it times the j. Plus, I go to the next one, 2 times negative I minus 3 times 3. Then I multiply everything times the k. So from there, I'll have 3 times 1, which gives you 3, minus negative 5 times negative 4, which is 20. So 3 minus 20 gives us negative 17. So here I end up with negative 17i. You go to the next one. 2 times 1 is a 2. 3 times negative 4 is a negative 12. But there is that negative, which makes it a positive, which becomes now positive 12. So 12 plus 2 is 14. But there is this negative here. So now it becomes negative 14 of the g. Then you go to the next one. 2 times negative 5 is negative 10. Minus 3 times 3 is 9. So you end up with negative 19k. So here you end up with negative 19k. And then you end at that point. Yes, I don't know. Are we on the same page? Are we on the same page? Are we on the same page? Yes, Martina?
Yeah, I don't know if we have arranged for us to do one where we have like 3. Okay, I don't know if it's possible to have like A times B times C.
Oh, okay. Now
Yeah.
that one, at this level, we do not do it. At this level, we don't cross more than 3 vectors. But that one, when you advance in math, you'll meet something of that nature. But here, we mainly stop at 2. Enough.
Oh, okay.
Okay. So I'm going to, okay. So, but I'm going to mainly, during the teaching, I think I'm going to mainly look at the second approach. Yeah, but feel free to use any approach. But let me now first give you and we first test on our own and see whether the concept now is there. So I'm giving you another one. We have C. I have negative 5. I have negative 5i minus 2j minus 2k. I have vector D is 2i plus 3j plus 3k. So members, find for me C cross D. Let us first try that on our own. But like I've said, no, use any approach. You are going to use any approach of your choice. It is okay. It's okay, Bands. Use any approach of your choice. Use any approach of your choice. The one that is easier. But like I've said, I'm going to mainly look at the second approach. That's the one I will be looking at, or the one I will be applying. But any approach of your choice is very okay. And never forget putting the sign positive, negative, positive. Otherwise, everything will turn out to be mm. Yes, another reason why we put positive, negative, positive, when you look at what we are going to cross, like when you remove J, you are crossing I cross K. So you notice I cross K will give you a negative J. So that is another reason why you put that negative. Yes, Ruth.
So good morning.
Morning.
I'm sorry for bothering you, but there is, am I forgetting the question? Oh, why are we using, I don't know if that is how for you write the brackets. Okay, because even in the chat, there were people who were asking that, okay, according to your explanation, it's sort of like a matrix method. So
Yes.
why using like modular signs instead of the normal brackets? I've forgotten what they call them. But yeah, the normal brackets.
Okay, now these brackets here, these ones, the cross, they represent determinant. They are showing us that we are getting determinant.
Okay.
Yeah.
So they have no effect on the signs, right?
On the signs?
Yes, because many times when we use
Oh, okay, yes, I get. But that represents what? Determinant.
oh, okay.
Yes. When it comes to, okay, that's what. So in matrix, the moment you find something like this in matrix, when you are dealing with matrix, this one, like when I find matrix A and they have written like this means find the determinant. Okay, I know people are trying. Looking through the chat, yeah, some have that. Some have J, 11J minus 11K, 11J minus, others have 11J minus 11K, 11J plus a negative. So, yeah, those who have 11J plus 11K, Liz, check out, something is not adding up. Something is not adding up. Maybe someone can raise up the hand and tell us. Okay. Yes, Gilbert. Which method have you used?
I've used the second approach.
Okay. How did you go about it?
So I began by eliminating. So if we eliminate the I and we put it outside, we put there -2, 3, -2, 3. Then -J, -5, 2, -2, 3. Then plus K, -5, 2, -2, 3.
Okay.
So we get the determinant. So for the first one is -2 times 3.
That one I'm going to just write the answer. Continue.
It's -2 times 3 minus -3 times 2. If you see, it is the same as -6 minus 6. sorry, -6 minus -6, which is 0.
Okay.
Then we have -5 times 3, which is -15, minus -2 times -2, which is -4. So -15 minus -4, it gives us -11.
Mm-hmm. So
11G.
negative. Okay.
11G. So then we get -5 times 3, which is -15, then minus 2 times -2, which is 4. So we get -15 minus -4, giving us -11. So there is plus -11. Okay. So the final answer we get -11J minus 11K.
Okay. Okay. So hope members that is okay. Vida.
Yes, good morning, Mister.
Morning.
Mister, my question is, on this first bracket, these signs we put, for I we put plus, for J we put negative, and for K we put plus. Do they show the direction?
Yes. Now that one, let me explain it. Now, Vida,
Yes, Mister.
when you look at my screen, are you seeing my screen?
Yes.
I want to explain it again in this format. When you look at I, when we are dealing with I, and I eliminate it, what am I crossing? I'm crossing J and K, right?
Right.
So when I'm crossing J and K, I get a positive I, right?
Yes, please.
So that's why here we put a positive. Now, if I go to J and I remove J, I'm crossing I and K.
And K.
So when you look at I and K, here you get what? Negative.
Yeah, negative.
A negative. When you get K, you're crossing I and J, which is positive.
Positive.
Yeah.
All right. Thank you, sir.
Yeah, thank you. Yes, if you don't look at it in that direction, you can look at it in that form of co-determinants. You can look at it in that form of sign change in those ends. If you want, you can look it at in that angle. Yeah. Or you can look it at the way you get your adjoints, positive, negative, negative, positive in that angle. Okay. Members, are we now on the same track? Are we good to continue? Are we good to continue? Okay, people are saying now we are good to continue. Okay, now let us now approach it in another format. Okay, now we are going to do this. So read through. Yes, Diana?
Teacher, sorry to take you back, but me, what I'm asking, like, after we are finished, like, cross multiplying for this, for the, then what do I do for the remaining one?
Like which remaining one?
Like, you see how we crossed and we're all like -2 times 3? Okay, like in the, like from the, I don't know how to explain it, but how to cross after cross multiplying this. Like when we are cross multiplying, then we say minus, then for the other one we add.
Like, because like we had a negative I, J, and K, then we had -5, -2, -2, then 2, 3, 3.
No, after eliminating.
Then we had something like this.
-2, 3. Negative.
Minus. Like this.
Yeah. E, and then after I multiplied the negative 2 times 3 plus minus negative 5 times 3 minus negative 5 times 3.
Oh, not Diana, do you remember how to get the determinant of a matrix?
All I
Do you
remember is
remember? What do you do? In case I have A, B, C, D, how do we get the determinant?
we shall multiply A times B.
Times D,
Then is it minus C
good.
times
Minus.
C times B?
Perfect. That is the same thing, Diana, we apply here. Apply and we see.
Negative 2 times 3 minus negative 2 times 3.
But we shall multiply with I.
I.
So negative 2 times 3 you end up with?
It is negative 6.
Minus?
Minus negative 15.
No. Remember, we are still on the first one, Diana.
Oh, yes, sorry. Negative 6.
So what do we end up with?
Would be 12.
Subtract 12. Negative 6.
Sorry. It will be 0.
0.
It will be
So
a
that's
0.
why. So that's...
So then we add for the other one, then plus.
This, okay, plus,
And then we do the same.
So what do you have here?
Negative 5 times 3 minus negative 2 times 2.
What do you get?
So it will be negative 15. And then negative 4.
Minus negative 4. But there is a negative J here, don't forget.
Yes. Then plus.
Here in brackets, what do you get?
Negative 5 minus. It will be negative 11J.
Negative 11. But there is a negative and a negative.
So it will be a positive.
So that's how.
Okay, thank you, sir.
Okay. So let me hope members have started to try out. Now, for this particular one, when they have asked us to find the direction of rotation, when we talk about direction of rotation, we are simply meaning the cross product. So that's what I do expect you to obtain. So I expect to obtain the cross product of A cross B. So let everyone do. Okay. Yes, Ruth?
Does this part of the scenario matter? This part that says this direction must be perpendicular to both forces acting on the arm.
Oh, yes. Now, in simple terms, they are trying even to give you a hint that whenever we are dealing with cross product, the answer or the vector that we get is always perpendicular to both of them.
Oh, okay.
So that is just a more hint to show you that now they are interested.
It's cross product.
It is cross product.
Thank you.
And once you make your calculations, you'll find out that the angle you are going to get, remember we looked at something to show that two vectors are perpendicular. So the answer you get, the moment you deal with it with one of the vectors, you'll find that the angle is 90 degrees. Yes, Diana? Okay. So can I look through the chat and I check out what members have obtained? Put your answer in the chat, those who have finished. Alex, check out. Shakira, check out. Okay, Kat, we look to be on the same track. Docas, check out. Hans, check out. Msmeta, yeah. Okay. Yeah, I'm saying quite the answers keep on differing. Some of it is because you are forgetting the negative. So Dan, check out. Uthman, yeah. Matia, check out. Alex, yeah. Anthony, Chiza, not yet. Doki, not yet. Julian, yeah. Yeah, I'm saying people, something is not adding up. Something is not adding up. And make sure, Bettina, not yet. You should not make any errors. Chizito, yeah. Josh, yeah. Norman, not yet. Jordan, not yet. We are not yet safe. We are not yet safe. Not yet safe. Motogi power, yeah. Jordan, not yet. JJ, not yet. Benson, not yet. Ken, no, not yet. Yeah, there's, I don't know, Melinda, yeah. There is some mistake people are making. There is some mistake people are making. Lillian, yeah. Okay, you can take us through how you are doing it, how you have done it. Lothia, Angel. And yes, Angel, yeah, Bettina, yeah. Okay, we can go on. Okay. Okay, Martina, it's okay. You can take us through.
Okay, teacher, mine is a question. Because I'm comparing the answers that I have to the ones in the chat, and everything is okay. I have 6J, I have positive 11K. Though for the I component, I'm getting 11 instead of negative 7.
Okay, we can start from there. Which approach have you used? The second, first?
The second one.
Okay. How have you done?
So I had 3 components, positive I, negative J, and then positive K. Then I said negative 3, positive 2, negative 3. That's for the first row. And then negative 1, negative 3, and positive 1. Then I began with the I component. So I said for the first row is going to be 2, negative 3. Then the second row, negative 3, 1, because we have eliminated the I component. Then for the J component, it's going to be negative J, 3, negative 3, negative 3 for the first column, then negative 1, 1 for the second row. And then K is going to be negative 3, 2, and then negative 1, negative 3.
Okay.
Now, specifically for the I component, what I did, I said 2 times 1, which when I got 2, and then minus negative 9, minus 9.
Okay.
Okay, which I have now seen. I was saying Yeah, I was saying +9 instead of -9.
Okay, complete.
Okay, so we get -7.
-7, eh?
Yes.
Okay.
Then for the J component, I got -3 times 1. That's on the major diagonal, yes, minus -3 times 1. So I got -3 minus -3, which was giving me
Come again.
-3 minus 3. Sorry. And then I was getting -6. But then the negative at the J affects it to get +6J. And then for K, I was getting, for the major diagonal, -3 times -3, and I was getting 9, plus the minor diagonal, it's 2 times -1. But then because we are subtracting, it will affect, so it will be 9 plus 2 to give us +11K.
Okay. Thank you. Yeah. Hope other members you have seen where the problem is. So Shiba, check out that negative. Patrick, it's okay. Gavanian. Gavanian. Okay. Yes. I'm happy to see the Gavanians again. That negative, check out Gavanian. Gloria, yes. Dr. Peace, yes. Imran, yes. Chome, yes. Dr. Mukisa, yes. Hope how you have seen where the mistake is, Rachel. Okay. Hope. Oh, just see check out now. Let me first answer some questions. Yes, Shakila. Okay. Shakila is not unmuting. Arnold?
Yes, sir. Good morning.
Morning.
Teacher, I don't know how that 11K is coming and even -7. For -7, okay, I've seen it. But the
Then
11K.
have you multiplied this? Are you seeing
Yes,
this?
sir. Yes. I
So
multiplied,
-3 times -3
which is
minus
9.
-1 times 2.
Yes.
So -3 times 3 is 9.
Yes. Oh, +2.
Plus 2.
Yes. Thank you, sir.
Okay. Hope. Yes, Shakira.
Okay, sir. I just want to inquire about the part of perpendicular. It must be perpendicular. You say the answer you get, like the answer you get shows that it's perpendicular. I just want you to help me in how to get that.
How to get that? Okay. Now,
On
do you
how to say that
remember?
it's perpendicular.
Okay. Do you remember how we proved that two vectors are perpendicular?
Yes, teacher.
What was the condition that two vectors are perpendicular?
Their cross product is 0.
Come again. Come again.
Okay, teacher, I
Shakira,
don't recall.
Okay, what did we look at in the last lesson? You remind us. We looked at which concept?
So I did attend the lesson.
Hey. Okay. So last time we looked at the dot product, yeah?
Yes, teacher.
So it was the dot product. So, and we said that the moment when we are dotting two vectors, okay, let me try to do it here. So, but Shakira, now you need to go back and look at those concepts because they are going to help you. Take an example. Shakira, here, like we have, I'm going to just extract. When you look at the answer we have, obtain is -7, 6, and 11. Is that fine?
Yes, teacher.
Now, one of the vectors we have here is -3, 2, and -3. Now, for two vectors to be perpendicular, when I get A dot B, the answer must be 0. Is that fine? So
Yes, teacher.
when we dot these two vectors, it means we shall have -7 times -3, which gives us, Shakira, do the math. -7 times 3 gives us
21.
21. Plus 6 times 2 gives us
12.
12. Plus 11 times -3 gives us.
-33.
And what do you get as your answer?
Let me see. 0.
0. So the moment you find that the dot product of those two vectors is 0, then it means they are perpendicular.
Okay, teacher. Thank you.
Okay. Yes. So members, that's how even you go on and prove that surely the answer you have got is very correct. The moment you cross, whenever it comes to cross product, the angle between the vector and the direction you have obtained should always be at cross at 90. Sometimes they can use the word orthogonal. Yeah. Yes, Shakira. I'm seeing your hand up. Okay. Members, I think we are good to continue. Now, where do we apply? Where do we apply? Now, one of the areas where we are going to apply the concept of cross product, one is going to be in these areas. One, it's going to be in obtaining the area. We are going to look at engineering design problems and also in surveying. So you have been looking at problems where they have told you to find the area of area of anything as long as they are vectors. So for us to be able to find the area of those particular things, we shall apply we are going to apply this particular concept. So I think we are going to start with the first one. Okay. Yes, Baswali.
Good morning, sir.
Morning.
Master, you hit on that word orthogonal, but I'm a bit confused on what it means.
Okay. Orthogonal, we are going to look at it again in details, but orthogonal is more or less, it means perpendicular. Is that okay?
Okay, teacher. Thank you.
So
okay,
sometimes,
sir.
in case you find them using the word orthogonal, orthogonal means at right angles. Yes,
okay,
so
sir.
that is the meanings. And that is when now they have brought in more mathematics. So whenever they talk about orthogonal means vectors that are perpendicular or that are at right angle. Yes, and that one, it's just even if they told that prove that these vectors are orthogonal, for you the moment you say that that is perpendicular. So A dot B should give you 0.
Oh, thank you, teacher.
Okay. So in other words, another term they can use for perpendicular. Yes, Shafi?
Good morning, sir.
Morning.
Mister, I'm sorry, but I beg your pardon on the previous formula for real.
Which formula?
The one we have just finished, that we have come to application of vectors.
Hey, that's what we are starting. We are starting it now.
Oh.
Hey. Now,
okay.
Now, where can some scenarios come from? So we can have a scenario whereby they are telling that show that the vertices are like the corners for a triangle. Now, whenever you have any triangle and you want to prove surely that what you have is a triangle, because not all figures that you have will form triangles. How do we prove it? Now, in order for us to prove that actually what we have, the vertices, the vectors that have been given to us form a triangle, what do? Now, we do what we call movement. So I will say A to B, B to C, and then C to A. So in other words, I would say vector A to B plus vector B to C plus vector C to E I must get 0. That the moment I add up all the vector components in this given direction, the answer I get must be 0. So whenever they tell that, prove that the vertices for the above that have been given of a triangle, this is how you are going to prove. That the moment you fold this, you get 0. But please, it's not a must that you must go A, B, B, C. As long as your triangle is crossed, even if you had something like this, let me say this is A, this is B, and this is C. Another person can decide to say A to C plus C to B plus B to A should give me 0. So whatever direction you take, as long as you have crossed there in the right direction, you must get 0. So that's how we prove that for any triangle, any vertices we have been given, that figure forms a triangle. The moment you get a 0, just know that the figure you have is a triangle. Members, are we good to continue? Is that okay? Okay. That a triangle is a crossed figure. In simple terms, a triangle is a crossed figure. So a crossed figure means that the moment you move across it, the moment like you see, let me, I'm just using this as a triangle. Let me say this is my figure. You know that for this one to prove, these two sides must be equal. This one must be equal. And when you move around, so these two must be equal, this must be 2. So, but for a triangle, when you are proving it, for you, as long as you move and you cross it, your answer will become 0. Okay, Geraldine, Alvan, Ken. Okay, so now we are going to continue to another one. Now, the second one is to show that a triangle given is a right angles. Now, we know very well that for any right angle, for any triangle to be a right angle, we know that always the angle we shall have at that point is going to be 90 degrees. So that is one thing you need to know. Now, for something to be or to prove that it's a right angle, in case, let me say, I label this as, let me say this is B, this is A, and this is my C. I want you to tell me in the chat, what do you think? What conditions will make this triangle? Or what do you need to do to ensure that the angle, because for a right angle, what is very important is to make sure that the angle here is 90 degrees. That is what is important. So what do you think is going to be the condition? What are you going to use? If this is our triangle, what do you think you're going to use to prove that this is a right triangle? Yes, Chome?
Yeah, I think the dot product of vector AB and BC is a 0.
The dot product of vector
AB and BC.
And this. Okay. This one should give you a 0. Thank you, Chome. Another person. Another person, they have given us a hint. Yes, Gilbert.
Mr. Kanti, the cross product B1.
Okay, I want us to build up. This, what he has mentioned is there, but there is something he has not done right. In regards to what we said in the past lesson, so that's why I want us now to build up from. What could be the mistake when you look at his dot product? Sebaiga or Ronald? There is something on that we need to look at.
Good morning, sir.
Good morning.
The product of AB dot CB is 0.
AB dot CB is 0. Okay,
yes.
Okay. Thank you. Okay. Now we are going to evaluate. Shafi, you have another opinion?
The dot product of.
Continue. Okay, so let's build up from here. Now, please and please do not forget we say that the moment you mention dot product and you want to find the angle, pay attention to two things. One, pay attention to the arrows that
Of BA dot
BA dot
the dot product
BC.
is 0.
Yes. So, members, always pay attention. We say that either the arrows must be moving from the same point. So that means you could either have BA, BA, and BC. So this is very okay, equals to 0. Alternatively, you could have these arrows coming at the same point. You could have them come at the same point like this, like this. So that means that that one is also okay. Having your vector BA dot BC. That one is also okay. They should either come from to the same point or go away from the same point. So someone who says AB dot CB is also okay. So please pay attention that whether arrows are coming to the same point or going away from the same point. Okay, so that one, yeah. But here, the only thing we need to do is we look out for the dot product. That because for right angles, we know that it is 90. So we can go with AB and then CB. Okay, even this one is okay. Yeah, but I can take on this one. Okay, so members, are we good to continue now? Is it okay? Is that concept fine? Oh. Bettina, I don't know what the problem is. Bettina?
Yes, teacher.
Yes, what could be the yes, morning?
So I got some network problems, and then I've just found in you saying B to A, B to C is 0. So pardon something on the right angle triangle.
Oh, like we know very that for a right angled triangle, the angle in there is 90 degrees. And being that it is 90 degrees, we say that for anything to be perpendicular, the dot product should equal to 0 from our previous lesson. So that's what we have said here, that the moment you dot BA and BC, you must be able to get 0.
So there is no interference if maybe you're coming from CB to BA.
CB to AB. CB to AB is okay because we say that arrows should either be moving to that point or going away from that point. So CB and AB is very okay.
Yes, thank you. I've got it.
Okay, now we go to another concept. Another concept is going to be the parallelogram. Now, when it comes to our parallelogram, like they have asked us to find the area. If this is A, this is my B, this is my C, and this is my D. Now, if we have two vectors, let me say this is vector A and this is vector D. So here, this is our vector A to B. This one is our vector A to D. And we know very well that this one is our height for a parallelogram. You know from your mathematics that the area of a parallelogram is given by, put in the chat, you can abbreviate me, I will understand. The area of a parallelogram is given by, the area of a parallelogram is given by, BH, very good. Is given by the base times your height. Now, if these two vectors, our angle here is theta, you can note that from our diagram here, our base is represented by our vector A to B. And we are multiplying. Allow me not to use this times because you may confuse it with the cross. times, so we are multiplying, times the height. But when you look at the height, I don't know whether members you remember from your knowledge of trigonometry, I have a figure of this nature, whereby this is A and this is D. The angle here is theta and this is H. So when you remember very well, you know that this is like your opposite and this is your hypotenuse. So when we apply sine of theta is equal to opposite out of the hypotenuse, which is A to D. So meaning that your H is the same as AD sine of theta. So that means that our height is given by A to D sine of theta. Members, hope that is still okay to everyone. Kindly let me know through the chat that that is very okay. What I've just written, AB.AD sine theta. Very good. Now, what are you going to notice? I'm going to remove this. So what you are going to notice is that we are multiplying 2. We are multiplying 2. So, and that area, being that area is a scalar quantity, we obtain the magnitude. Because area is scalar, so that means I have magnitude of AB, magnitude of AD should give me sine of theta. And this is the area of the parallelogram. But I want to take you back from our definition of what we call the cross product. That if I have A to D and this is my B, and the angle between them is theta, we say that if by definition our A to D, remember they must have a common point, cross A to B is given by magnitude of AD, magnitude of AB, sine of theta. Now, you notice very well that the whole of this side here is the same as what we have as our area. And therefore, you can say now that the area of a parallelogram is given by this. So it's given by AD cross AB. So that is where we get that formula, that area of a parallelogram is given by AD cross AB, or someone can say AB cross AD. Any of the two is very correct. Members, is that okay? Are we on the same page? Okay, can we write it down now and we continue? So it means that if you have an angle, you use the first one. If you have no angle, you use the second one. So it depends on what you have for you to be able to apply. So you think through and say, now I have this one. This could be the appropriate formula. Yes, Prince.
Yes, good morning, Master.
Morning.
I would please like you to repeat where I have stated area is equal to AB AD sine theta.
Where? Here?
Yes.
Like here, we said, hope you understood this second step because it is coming from here.
Master, you can start from there.
Because you know that we say that area of a parallelogram is given by base times the height. Now, when you look at our base, on our base we have A to B. So that's why here we have A, B, times the height. But we say that when you look at the height of a parallelogram, it is this angle between the two vectors. This is your opposite and this is your hypotenuse. And when we go back to SOHCAHTOA, we know that sine of any angle is given by opposite out of the hypotenuse. So your opposite is the height. Your hypotenuse is this side here, which is A to D, equals to sine of theta. But since we are interested in H, we cross multiply and we end up with H equals to AD sine of theta. So where there is H, you put AD sine of theta. So that's where it comes from.
Okay, Master.
Okay. Okay, Shafi?
Mister, I beg you for pardon on the cross formula.
Now, this cross formula, I hope you were around when we are starting the lesson. We said this came from the definition of a cross product, that this is just the definition. And we say that if you have two vectors A and B, and the angle between them is theta, you are asking yourself, which direction should I take such that that vector is perpendicular to both vectors? And we say that by definition, A cross B is the same as vector A, magnitude of vector B times sine of theta. So here
Okay,
we are just implying. Okay. I think members we can continue. We can continue. Then the last one I want to look at. The last one is the area of a triangle. Now, when it comes to the area of a triangle, I have two ways you can do it. Number one, if this angle here is theta, you know very well from your definition. I don't know which one should I use. I can use, you looked at it, you looked at this concept when you are looking at sine rule, you looked at something of this nature, but we know that the area of any triangle is given by half base times its height. Now from here, you notice that our base is A to B. That is our base. Then, what is our height? This is the height we have. And still you are going to use the same concept, that height, we shall say that height, we use sine, you say sine theta is equal to height out of A to C. And therefore your height will become SC sine of theta. So this is the same as SC sine of theta. And here we are interested in the magnitude. Now, when you come from here, this is one formula you can use. And this is what you quoted when you were looking at in senior 4 trigonometry. When you're looking at that trigonometry of senior 3, you equated something like that for area of a triangle. But now, if we bring in the knowledge of cross product, we say that if this is our reference point A, this is point B and C, and this is the angle theta, it means that when you have AB cross SC, you'll end up with AB cross SC sine of theta. Now, where there is the whole of this, you can now put this. So the area of any triangle can be given by vector AB cross vector A to C. Hope that is okay. And please take note that these are magnitudes. These are magnitudes. Don't forget, area is a scalar. Area is a scalar. So you have to get the magnitudes. Let me hope we also place the magnitude. I think I might have forgotten them here on the parallelogram. But please don't forget it is magnitude. So in case we did not place them at the area of, we did not place the magnitude, place them there. It is the magnitude. Hope that is okay. The other approach someone could use, like you know that a parallelogram, in case I don't use this approach, you can as well come and say, but a parallelogram is half a triangle. Those who know it, that a parallelogram is always half. When I divide like this is half, this is half, and this is now a triangle. So you can say that the area of a parallelogram is half the one. So you can just even come and say, for a parallelogram, remember we had A, B, and this was, I think, D, and this was C. So you can as well come and say this is a half, AB, I think, AB cross A to D. That one can as well work. Yeah, in case you have used that approach. Yeah, but don't forget, go back and check. I don't know whether I forgot, but it must be in magnitude. You shouldn't remain with a vector. Okay, let me answer only Gilbert. Yes, Gilbert.
Yes, master. Like you say that this formula is the one we used when we are looking at trigonometry at O level. So like they used to tell us that for any triangle with one known angle and two sides that make up that angle and have the known length, we can use that does it mean that we can use the same formula even when the known angle is at B or C?
Yes, anywhere. Anywhere. But do not forget the condition. I've told that the condition is that what you extract here must have a reference point where that angle is placed.
Okay, sir.
The reference angle matters because if the angle now, for this case, the angle was at C and this was theta and this was A and this was B, then this one cannot be my formula. Now, instead, my formula will be a half. In case this is a triangle, it will be a half. Then I'll have the magnitude of CA cross CB. So you have to pay attention where the angle is. Okay, members. Okay, so I think we are going to continue. So we are going to apply everything we have learned. So this is the first activity. I'm going to ask each one of you. You are going to first try the first part. Feel free always to have a sketch. So they have told us that 3 points A, B, C show that the points are vertices of a triangle. Like we say, to show that something is a vertex, you say A, B, and C. And then you cross. You say A, B, B, C, and S. Then you say that for points to be, for the point to show that points are vertices of a triangle, the AB plus BC plus CA should equal to 0. Why I want you now to first try, everyone first try on your own, and you prove that you get a 0. Do not forget we looked at displacement vectors and we said that when you have AB is the same as OB minus OA. When you have BC, BC is the same as OC minus OB. When we have CA, you have this and this. So I expect you to first find vector AB, find vector BC, find vector CA. So can we do that? Let's okay. Okay, Bettina says she's getting 0. They are vertices. Has everyone proved that they are vertices? Anyone who needs support, you can raise up the hand. Anyone who says that maybe I need some support? Okay. Yes, Christopher. Christopher? Oh, Christopher is not unmuting. Okay. Maybe someone can raise up and they tell us what they have got for A, B, B, C, and yes, Christopher.
So how do we How do we prove the points that they are vertices?
This is the condition. Are you seeing this condition? This is the condition. So do you know how to get AB?
Pardon?
Do you know how to get AB?
No?
No. Could this be the first lesson? Oh. Do you remember that O level? Okay, let me see. Stay on. Santos.
Good morning, sir.
Morning.
I think this is what I've done. I've got 000. I first of all got vector AB. Simply by saying vector AB equals to OB minus OA.
OA. Okay.
Then it is 874. Then minus 331. And you end up getting 543.
Okay.
I went ahead and calculated BC, whereby BC is the same as vector OC minus OB. 745 minus 874. Getting 3 negative 31.
3?
3 negative 3 and
Okay.
then I went ahead and
a minute. Let me ask Christopher, are you picking something?
Yes, sir.
Christopher, first tell me what is CA? How do you get CA?
That is OA minus OC.
Continue. What is your OA?
OA is 331 minus 1145.
Okay. What do you end up with?
Negative 8. Negative 1. Negative 4.
Okay. Okay, Santos, we continue.
Then after me obtaining those individual vectors, vector AB, BC, then and A, I went ahead and said that if I move from A to B, B to C, and C to A, it means that my placement has to be a 0. So I went ahead and finally added those vectors I got. So I added AB, which is 543, plus BC, which is 3 negative 31, and that's last AC, whereby AC is negative 4, and I end up getting 000.
Okay. Okay.
Right.
Thank you. Thank you. So let me hope, Christopher, you have got it.
Yes.
Okay. So members, that's how we get it. And now you conclude that since AB plus BC plus CA is 0, therefore the ABC are vertices of a triangle. And they are told us that hence find the area of the triangle. Now when we are finding the area, now since we do not have the angle here, then I do expect you to use, okay, let me remove this, but for you, we are going to do it. So since I am interested in finding the area of the triangle, then it means that you go on and apply. But we say that when you are finding the area, make sure that you have a common point. So someone can say, me, I want here. Are you seeing? So I can say A, B, and C. So someone can say that area of a triangle is given by a half magnitude. Please take note, magnitude. A to C cross A to B. There must be a common point. A to C, A to B. Another formula, please do not be constrained on this. Another person can, for me, I want here, C to be my reference point. So another person can say, my area can be C to A, C to B. That one is also very fine. Hey, cross C to B. Another person can say, ah, for me, I don't want. I want it that side. So you can have B to A, B to C. You get the same what? The same answer. So wherever you want, please go on and do. Yeah. Okay, Dr. Peace.
Teacher,
Yes.
I just wanted to know because they have said the triangle is ABC. I thought that we take the angle to be at the middle letter, that we take the angle to be at B.
Or at B. Now, when it comes to area being that it is a scalar quantity. Are you getting it?
Yes, teacher.
So for area, for the triangle, no matter where you have positioned your angle, the angle remains the same. But if they had told us to find the angle, that would be very okay, doctor.
Okay, teacher, thank you.
But take us through, don't go away now. Let me first clean and you'll be taking us through as members are also trying out. Hope, doctor, you're still on.
Yes.
Take us through. What have you done or what are you going to do?
What we are going to do is that area is equal to a half. For me, I've considered a half magnitude of AB times CB.
AB
times CB.
Why?
Because I've considered
what is your reference point?
B.
Okay, if it is B, so B, what could be the right vector for you to drive? And which direction are you taking?
I'm taking the anti-clockwise. And
Okay. You are starting to move from B towards what?
I'm starting to move from A towards B, then from B to C. Like I'm
Okay.
taking the angle to
Where are you placing your angle? Where are you placing your angle?
at B.
At B. Now, doctor, if we place our angle at B,
Yes,
it means
teacher.
that you are going to move from B towards C and then B towards A.
Okay, I thought that even if we move, okay, yeah, I've got it now. I've got it.
Explain what you have got now.
What I've got, okay. For me, I was still looked the other side where we were last time. That when you move, we can either move towards the angle or away from it.
Okay, even that one works, doctor. That one works. You can take us through that.
So AB and
FB
CB.
and
CB.
okay.
AB times CB.
CB.
So we had our AB already from the previous calculations, but we didn't get the CB. Let us try to get the CB. It is OB minus OC. So which is 87874 minus 1145. So when we subtract there, we shall have 3. 3. 7 minus 4. Again 3. Then 4 minus 5. -1. So then we go back up in our formula and we substitute in. So area is equal to a half magnitude of AB, which was 5.
Magnitude of?
AB. I think now we can substitute it.
Remember, you have to cross first.
Okay. Let us first cross those two. So we shall have AB times CB. It will be equal to, yes, but negative J.
Oh, sorry. Hey, is it the one? Wait.
So we
It
put
will
in
be.
we
What
put
was
in
your
our,
AB?
it was 5, 4, 3. Then we also put in the what? The CB, 3, 3, negative 1.
So here, just give us the summary. Do your calculations and give us the summary.
Okay.
Stay on, doctor. Don't mute as I pick on Rose. Rose?
Okay.
Yes, teacher. Like 8
Yes.
minus 11 is negative 3.
8 minus? Oh, here.
Yeah.
Okay. Okay. Thank you. Thank you. Okay. Rose?
Yes, teacher.
Oh, is it the same thing?
Yeah.
Okay. So members, in case you have got that cross, you can tell us what you are getting for anything you have been able to cross. Okay. Okay, some people have already started getting the answers. Please go on. Doctor, please give us the summary of here, what you are getting.
The step after getting the determinant, it's negative 4 minus 9.
Give me just, for me, I want that summary, that maybe this I, this J, K.
Okay, let me first sum up. It is negative 13I plus 14J plus 3.
Plus 3.
Yes, plus 3K.
Oh, yeah.
That's what I'm getting there. I
Okay,
don't know.
I don't know.
I don't know if
Okay.
it's okay.
Okay, go on and get, let me check. I'm going to first compare with people's answers in the chat, and we see whether members, after getting 13, let me check. 15 minus negative 12. Oh, something as if it's okay. Okay. Something here is not adding up.
Instead of 3, I think it's 27. I had forgotten the negative sign after multiplying negative 3 and
Okay.
so we shall have it's now a plus 27. Okay.
Okay, what about here? As if this is also supposed to be 4. Minus 4J.
Let me see. Yes, it is supposed to be, but I'm saying it's supposed to be a positive 4.
Positive 4?
Let me see.
Don't
It's a,
forget the negative sign here.
yes, it's a negative 4.
Okay, okay. So I'm looking through the chat. Now, members, some of you are getting 13 for negative 27. Those who are getting this answer as well, let me show you. Those who are getting this answer of 13i plus 4j minus 27k, you are also very correct. You are very correct. So your answers should either be like this or like this. Okay, okay. I think the answers I'm seeing in the chat are okay. They are very okay. They are very okay. Good, good, good. Now, after that, we are going to get the what? We are going to get the magnitude. We are going to get the magnitude. Doctor, how do you get the magnitude?
We shall get the magnitude by squaring the components in each. So we shall have negative 13. All right, let us first write that.
So we shall have?
Negative 13 squared plus negative 4 squared plus 27 squared. Let me try to compute and I see the answer.
Okay.
It is root of 914 and I think it doesn't have a perfect whatever. So, which is 30.2324. So, teacher, aren't you going to get the half of it?
What? Then we get the half, eh?
Yes.
Okay, so we are going to multiply times the half. Okay. So the answer here, we divide by 2. So we end up with?
We end up with 15.1162.
Okay, 15.116. Okay, square units. We can have this.
Okay. Thank you, sir.
Okay, thank you, doctor. Members, are we on the same page? Anyone we are leaving behind? Hence, hearts, something like that. Unmute.
Sir, good morning.
Morning.
So at first, as for me, I use the other way, which is also one. You can talk about half the limus SC times AB nze mbadde nkozesezza.
Yes, you have used which one? SC?
It's
Cross?
a half.
Okay,
Yes.
half.
Then AB.
B,
SC
cross.
times.
This is cross. SC.
Cross AB.
AB. Yes, you get the same answer.
Okay. Then I nfunye one of it. Funye negative 13i minus 4j then plus 27k.
Yes, that is very okay. Okay. Then lastly, Lydian.
Good morning, teacher.
Morning.
How do you know where to use the cross product and the dot product?
Oh, now like I said earlier on, that we looked at applications of each, right? So I showed you the applications of dot products, and now I'm showing you the applications of cross product. And I've said cross product will support you in finding the area. So when it comes to area of a triangle, area of parallelogram, all those ones, it will be this kind of concept.
Okay.
So now for you need to know the kind of application and what has been given to you. So that is what you base on to say now, this is what I have to go for. But with practice, I know we shall get there. Okay. I think at this moment, okay, I think our time is up, but maybe I just give you I just give you this as your activity you're going to try out. One, I want to first just give you one. Take a screenshot and I give you another one. So here you have to determine whether they are vertices, then determine whether it is a right angle. So here you are not now, you are going to, you require now to know about three up. You need to know you need to know the cross product, you need to know the dot product for you to be able to do this. Then I'm going to, let me display one more number, just one more number. Another number is here. Okay. Okay, but I know you are going to try this one. Then tomorrow, when we meet, we shall. Okay, we have remained with about more 3 activities. 1, 2. Okay, about more 4. We still have some scenarios we shall deal with tomorrow. Okay, unless there is any burning question, but we shall end here for today, and then we start from here. Let me just pick on just one hand. Yes, Hudson.
Oh no, master. Sorry, but I'm fine.
Okay. Yes, please.
Teacher, thank you so much.
You're welcome, please. Okay. So let's meet tomorrow and have a good day. Bye bye, everyone.